Alright, here's our Chapter 5 review. This is the first part of Chapter 5. So on the first couple pages, I'm going to go through these problems not in order. I'm going to kind of jump around based on the type of problems that they are. So the first problem I'm going to start on, I think, is just number 5. Yeah, so I'm going to jump into number 5 and start talking about the exponent rules. So the idea is we need to have as few numbers and letters as possible and in the right spot. So the first thing I'm going to do is deal with the parentheses, and I'm going to distribute that exponent. So when I distribute that, distributing is always multiplying. So this numerator is going to be replaced by u to the -4th and v to the -2. So this numerator's gone, and that's our new numerator. And I'm going to do a little organizing. So I'm going to be making the houses, and I'm just going to go, left to right, top to bottom, and put these things in the right spot. So any negative exponents will be moving. So I'll be making the first house for the number. So this u will be going in the bottom, and that v will be going in the bottom, and they are both moving because they're negative exponents. When I go to the denominator, the 2 will stay in the bottom. There's no negative exponent attached. The v will stay there. This u, however, will be going to the top because it's negative. This 2 will be staying, and that u will be staying where it is. So then you can go to your different houses and start to clean them up. So this fraction bar is for my answer. When I'm done here, I have a total of 3 v's. In my u's, in the bottom right now, I have a total of 5. So when I do subtract them, I'll have 2 left over, and they will be in the bottom because that's where most of the u's are. And then I'm going to multiply, and I guess you could add them, but that's technically not right, and I'll get 4. And to show it's a denominator, I need a numerator. So the next problem I'm going to jump to is actually I'm going to jump to the next page, and I want to take a look at 13 and 14. So 13, the rules are going to be the same, except I just happen to have an exponent, or a fraction that's an exponent. So the 1/2 is going to distribute to the 16, to the 10, and it's going to go to the 25. So I'm going to start with the 25. It's going to be 25 to the 1/2. I'm going to multiply half with 10. I'm going to get 5. And I'm going to multiply half with 16, and I'm going to get 8. Now, as far as organizing, it's pretty well organized. But what you need to remember is that kind of in the beginning of the notes packet, but we talked about that a 1/2 power is a square root. And so you should take that 25, look at it as a square root of 25, and turn it into 5, and then put this. You cannot leave 25 to the 1/2 as a 1/2. If it was 5 to the 2nd power, I know you guys know 5 to the 2nd power, and I would be fine if you left it like that. But I do need for you to demonstrate that you know that a 1/2 is a square root, just like a 1/3 is a cube root, a 1/4 is a 4th root. So this one is done. So 14, same thing. I've got some parentheses, so I'm going to distribute this 2. I'm going to start with the numerator. And here comes the new numerator. I will take 2 and square it. That'll be 4. I'm going to take 2 times a third. So on the test, I'm going to suggest that you just have a random piece of paper out. And if you need a piece of paper to multiply 2 with 1/3, you multiply across and you get 2/3. So x's new power will be x to the 2/3. And then I'm going to multiply the 2 with the -2 and get z to the -4th. But because the parentheses go to the whole thing, I'm going to multiply the 2 to the 1/2, and half of 2 is 1. I'm going to take 2 times 3, and that's 6. And I'm going to take 2 to the 4th to 4, and that means 4 squared, so that'll be 16. So now what I'm going to do is make my houses, and I'm going to do a little bit of moving, not much. The 4 and 16 will stay where they are. The x's will stay where they are. And my z to the -4th will join the z in the bottom. So what's the easiest house to clean up? Probably the z's. Here's my answer. There will be 5 of those. 4/16, you can divide both of those by 4 and get 1/4. So that's probably the next easiest house to deal with. And then this, I'm supposed to subtract 6 and 2/3. So again, I would take my little piece of paper out, and if I take 6, I almost said sacks, and subtract 2/3, I will need common denominators, which will be 3. And so to get to 3, I'm going to have to multiply both of these by 3, and that will become 18 thirds minus 2 thirds. And when I'm done subtracting, I'll have 16 thirds. So that'll be my new exponent attached to the x. But where does the x go? Well, 6 is definitely bigger than 2 thirds. So that new exponent of 16 thirds will be on the bottom. I'm going to put it at the end because it's just going to fit there better. And this will be your answer for 14. So the next couple problems I want to take a look at. Oh, sorry, now I want to do 12. So again, I'm just going to distribute, and 2 times negative 1/3. So again, I can take 2 times negative 1/3. I need this to be a fraction, and you multiply and you get negative 2 thirds. And right now, that's on the bottom, because that's where it was. But then when I organize it and I move it, I'm done, because it should be in the top. Negative exponents move. And there's nothing to organize. There was only one thing there. So the next type of problem I want to take a look at, for instance, is 16. So again, you're not going to have a calculator with this section, so you need to be able to tell me what 27 to the negative 4 thirds is without using your calculator. So first I'm going to use the exponent rule that says that moves down. Okay, that's one way to do the problem. But then what I'm going to do is I'm going to rewrite this as a radical. So the 27 is going to go here, and the denominator goes like that, and the 4 becomes the numerator. And then you should know that the cubed root of 27, we've done this enough now, is 3. And then you can take 3 to the 4th power, so 3 times 3 times 3 times 3. And if you're like, I can't do that, yes you can. That's 9. That's 9. And when you get 9 and 9, you get 81. So when you're done, this is 1 over 81. So with that, I'm going to go back to the first page and address a few more of these. So I'm just going to take a look, actually just at number 1. So the other way I could have done this problem is rewrite it as the radical first, treat the 1 as a negative 1, and then do the cubed root of 27, that's 3. And then the negative says move it down. I could have moved it down first and still get the same answer. So the problems I want to take care of next are kind of a set of them. I'm going to jump to number 7 and dealing with that perfect and not perfect. So again, we need to get as much out of there as possible. So if you don't know 32, you need to, the rest of these we will be making factor trees pretty much. So I would take my other piece of paper, break it down, and when I'm done, I have 1, 2, 3, 4, 5, 2. So I'm going to rewrite that 32 as 2 to the 5th power. Everything else is just coming along. There's a little 2 here, that helps. And I showed you the faster way to do that, and that's how I'm going to deal with this problem. Stuff will come out, stuff will stay in. So I'm going to start with the 2. The 2 will come out. 2 goes into 5 2 times. That's 4. And when you take that 4 and subtract it from the 5, you get 1 left over. And 2 goes into 3, the x will be coming out then. 2 goes into 3 1 time. When you take that 2 times 1, that's 2, subtract it from the 3, and you get 1 left over. And the y's will be coming out. 2 goes into 9 4 times, and when you finish that division, you get 1 left over. And then 2 goes into 8 perfectly, so all of those z's will be coming out. You may put the first powers, you don't have to put the first powers. This is a great answer. It would be better if you did change this 2 squared into a 4 for the most complete answer. So another problem that's similar to that is number 9. So now I'm jumping to number 9. And that's a cubed root, kind of hard to see here. But I would take my other piece of paper, I would make a factor tree of 64. So I'd start with 8s, and then 2 and 4 and 2 and 4, and then the 2's all break down. So when I'm done, I have 1, 2, 3, 4, 5, 6. I'm going to the end of the branches and counting. So I'm going to rewrite 64 as 2 to the 6th, and then there's an x to the 4th and y squared. This will be the stuff that's coming out, and here's the cubed root. So all the 2's will be coming out because 3 goes into 6 twice. The x's the x's will be coming out. 3 goes into 4 once, and when you're done you'll have 1 left over. And then 3 never goes into 2, it can't, so that will be stuck there. So again, a great answer, but if you could go that one step further, turn that into a 4, that is the better answer. So number 11. Number 11, what I'm going to do is make it look like number 9. So since they're both fifth roots, I'm just going to multiply my 27 and 9. And when I do that, I think I get, what, 243? And I'm going to put my x's together. And this is a fifth root. So what I'm going to do now is this problem is just like 9. I'm going to make a factor tree of 243. And the nice thing is I already know how to break it down. So why did I do that? I don't know. I'll be breaking it back down. So this goes into 9 and 3, 3 and 3, 3 and 3. And if I count the last of the branches, I've got 5 3s. So I'm going to rewrite 243 as 3 to the 5th and x to the 5th. And sorry, you couldn't see that. So 243, now 3 to the 5th, and now these are both perfect. They'll both come out as 3x. So let's take a look at some of the other problems in this part. So let's start with the type that looks like 3. So the first thing we're going to do when we're in this is just we're going to go inside of here and we're going to simplify it as much as possible. So 32 I can't do much with, but I don't need all of the x's. I can rewrite it as 32 x cubed, and then I would just have a 1 on top. And then we just break them up into 2. And then I would make a factor tree for 32. And I already made a factor tree for 32. Here it was 2 to the 5th power. So what I'm doing is just rewriting this. And I think that's the biggest mistake I'm seeing, is that we're not making the factor tree for 32. So we had 3 rules. One is no radical can be, or there can't be a fraction under the radical. I fixed that. I broke it up. The second rule is I can't have a radical in the denominator. So now I'm going to fix that with another square root. I'm going to make this perfect, because if it's perfect and all the stuff can come out, I don't have a radical in the denominator. So I just have to think about how many more 2's do I need. I have 5, and if I have 1 more, then I have 6, and 6 is perfect. And the x's, I have 3, and if I put 1 more, now I have 4, and 4 is perfect. And then if you remember, whatever you do to the bottom, you do to the top. You can put the 1's there if you want. And now what we're going to do is we're just going to make this, instead of 2 denominators, we're going to make it 1 denominator. So I'm going to put my 2's together. There's 6 of them. I'm going to put my x's together. There's 4 of them. And then I'm going to put my numerators together. You don't need the 1. We discussed that. I'll just put the x and the 2. And now I'm going to take everything out that's perfect. And we made the denominator perfect. The 2 will come out, 2 to the 3rd. The x will come out, x to the 2nd. There are not enough in the top to come out, so they will stay that way. And this is a great answer. If you think about it, maybe you could go that one step further and turn 2 to the 3rd into 8. So another problem that's similar to that is number 8. And you know, when you do this on the test, you don't have to go left to right. You can do, group them like how I'm grouping them. So let's take a look at number 8.